Welcome back, science enthusiasts! Today, we're diving into the world of chemistry to explore some of the most dangerous chemical reactions ever. These reactions are explosive, deadly, and downright fascinating. So, buckle up, put on your safety goggles, and get ready for a wild ride as we explore the explosive world of some of the most dangerous chemical reactions known to humankind. Alright folks, let's kick things off with a classic sodium and water. Now, you might think of sodium as that harmless little element on the periodic table, or maybe you remember it from those salt packets you snag at the drive-thru. And water? Well, that's just like everywhere, right? But when you bring these two seemingly innocent substances together, things get explosively interesting. You see, sodium is a highly reactive metal. It's so eager to get rid of its outermost electron that it'll readily donate it to water molecules. This electron transfer sets off a chain reaction, literally. The reaction releases a ton of energy in the form of heat and light, and as a byproduct it produces hydrogen gas. The heat generated by the reaction is often enough to ignite the hydrogen gas, resulting in a spectacular explosion. And I'm not talking about a little poof of smoke here. We're talking about a serious kaboom that can send chunks of sodium metal flying through the air. To really understand the power of this reaction, imagine dropping a chunk of sodium the size of a pea into a bowl of water. The reaction is so violent that it can shatter the bowl, sending shards of glass and burning sodium everywhere. But why is sodium so reactive with water in the first place? Well, it all comes down to its atomic structure. Sodium only has one electron in its outermost energy level, and it really wants to get rid of it to achieve a stable electron configuration. Water molecules, with their partially positive hydrogen atoms, are the perfect target for sodium's electron donation. Sodium and water, a seemingly harmless combination that can turn explosive in an instant. Now that we've dipped our toes into the world of explosive chemistry with sodium and water, let's crank things up a notch. Potassium chlorate and sugar are definitely in a league of their own. Potassium chlorate is a powerful oxidizing agent. Think of it like the ultimate electron thief, constantly on the lookout to snatch electrons from other substances. And sugar? Well, sugar is packed with carbon and hydrogen atoms which just so happen to be loaded with electrons that potassium chlorate desperately craves. When you mix these two together, you're essentially setting up a chemical tug-of-war with potassium chlorate pulling electrons from the sugar molecules. As potassium chlorate rips electrons away from the sugar, it breaks down the sugar molecules into carbon dioxide, water, and a whole lot of energy. This reaction releases so much heat that it can ignite the surrounding materials, creating a blazing inferno. The real kicker is that potassium chlorate is also a powerful source of oxygen. So not only does it provide the fuel for the fire by breaking down the sugar, but it also feeds the flames with a steady supply of oxygen, making the fire even more intense. Imagine mixing a small amount of potassium chlorate and sugar together, and then adding a drop of concentrated sulfuric acid. The acid acts as a catalyst, kickstarting the reaction and causing the mixture to instantly burst into flames with a loud whoosh. Potassium chlorate and sugar are a potent reminder that even seemingly harmless substances like sugar can become incredibly dangerous when mixed with the wrong ingredients. We've seen sodium explode in water, we've witnessed the fiery fury of potassium chlorate and sugar, but now it's time to crank the reactivity dial up to 11 with cesium and water. This, my friends, is a reaction that makes sodium look like a kiddie pool compared to a tsunami. Cesium is one of the most reactive elements on the periodic table. It's so eager to get rid of its outermost electron that it'll practically throw it at anything that comes near it. And water? Well, let's just say water molecules don't stand a chance against cesium's electron-donating fury. When cesium comes into contact with water, it explodes with a force that can shatter glass and send shrapnel flying. The reaction is so violent because cesium only needs the tiniest bit of activation energy to ditch its electron. Even the slightest nudge from a water molecule is enough to set it off. The explosion from cesium and water isn't just about the initial blast, it's about the chain reaction that follows. The heat generated by the initial explosion is enough to ignite the surrounding hydrogen gas, which, as we learned earlier, is highly flammable. This creates a secondary explosion that's even more powerful than the first. The cesium hydroxide produced in the reaction is also highly corrosive, so even if you manage to avoid the explosion, you're still in danger of getting a nasty chemical burn. Imagine dropping a small piece of cesium into a bathtub full of water. The resulting explosion would be so powerful that it could blow the bathtub to smithereens, sending shards of porcelain and scalding hot water flying in all directions. Cesium and water are a testament to the incredible power of chemical reactions, and a stark reminder that sometimes it's best to just admire the reactivity from a safe distance. We've talked about some pretty reactive substances so far, but now it's time to introduce you to the ultimate bad boy of the periodic table, chlorine trifluoride. This chemical is so reactive, so volatile, so downright dangerous that it makes even the most seasoned chemists break out in a cold sweat. Chlorine trifluoride is a pale green liquid that's best known for its ability to set just about anything on fire. And I mean anything. We're talking wood, glass, concrete, even asbestos, which is supposed to be fireproof. This stuff laughs in the face of fire safety regulations. But what makes chlorine trifluoride so incredibly reactive? Well, it all comes down to its unique chemical structure and the sheer strength of its oxidizing power. Chlorine trifluoride is a powerful fluorinating agent, which means it's really good at sticking fluorine atoms onto other molecules. And fluorine, my friends, is the most electronegative element on the periodic table. It's like the electron-hungry black hole of the chemical world. When chlorine trifluoride comes into contact with something like, say, a piece of wood, the fluorine atoms go absolutely nuts. They rip electrons away from the wood molecules with such ferocity that they cause the wood to spontaneously combust. And because chlorine trifluoride also provides its own oxygen for the reaction, the fire burns even hotter and faster. But it's not just organic materials that chlorine trifluoride likes to set on fire. It can also ignite things like sand, water, and even ice. That's right, this chemical is so reactive that it can make ice burn. Chlorine trifluoride is so corrosive that it eats through just about every known material. The only way to safely store chlorine trifluoride is in specially designed containers made from materials like nickel or monel, a nickel-copper alloy. Chlorine trifluoride is definitely not something you want to mess around with. It's a chemical that demands respect, caution, and a healthy dose of fear. We've seen some pretty wild reactions so far, but now it's time to introduce you to a substance that's so sensitive, so prone to detonation, that it makes nitroglycerin look like a pacifist. I'm talking about nitrogen triiodide, the chemical equivalent of that one friend who freaks out if you breathe too loudly in their direction. Nitrogen triiodide is a dark brown solid that's best known for its extreme sensitivity to shock, friction, and, well, pretty much any kind of external stimulus. Even the slightest touch, a gentle breeze, or the impact of a single fly landing on it can be enough to set it off. Nitrogen triiodide is made up of one nitrogen atom bonded to 3 iodine atoms. And iodine, my friends, is a big, bulky atom that really doesn't like being crowded. In the nitrogen triiodide molecule, the 3 iodine atoms are forced into close proximity with each other, creating a lot of steric strain. It's like trying to cram 3 sumo wrestlers into a phone booth. There's just not enough room for everyone to be comfortable. This steric strain makes the nitrogen-iodine bonds incredibly weak and prone to breaking. And when those bonds break, they do so with a bang. The nitrogen atoms quickly recombine to form nitrogen gas, while the iodine atoms are released as a purple cloud of vapor. The decomposition of nitrogen triiodide is so exothermic, meaning it releases a lot of energy, that it creates a loud snapping sound and a bright flash of light. To give you an idea of just how sensitive nitrogen triiodide is, imagine placing a single crystal of it on a piece of paper. If you were to then gently touch the crystal with a feather, it would instantly detonate, leaving a small hole in the paper and a faint purple stain from the iodine vapor. Nitrogen triiodide is definitely not something you want to mess around with. It's a chemical that demands the utmost respect, caution, and a healthy dose of paranoia. Thanks for watching. If you enjoyed this video, make sure to give it a thumbs up and subscribe for more fascinating science content. Stay curious and stay safe.